In this video, we're going to be covering a lot of rules and a lot of definitions, so make sure to take notes, pause often, and complete the U-tries on your own. Now, in the previous example videos, we did a complement, but the complement rule basically says that if we're looking for not A, we can just do 1 minus the probability of A. The addition rule, we use the addition rule when we're talking about or at least one. Okay, and so what's really important here, and we talked about this briefly before, is we don't want to count that middle, right? So to not count that middle, we subtract the intersection of the two. So we would add the two probabilities and then make sure to subtract any intersection. Let's do an example here. At Germantown Academy, 60% of students play a fall sport and 52% of students play a spring sport. 35% of students play both seasons. So what is the probability that a randomly selected student plays at least one season? So here, let's just kind of put this into terms here. So we've got the probability of a fall sport is 0.60, and the probability of a spring sport is 0.52. And the probability of both fall and spring is 0.35. So we want to know at least one. At least one is going to be our union here. So we want to know the probability of fall or spring. So that's the probability of fall plus the probability of spring, subtracting any overlap, that intersection between the two. So that would be 0.60 plus 0.52 minus 0.35. And we end up getting 0.77. So it's the probability is 77% that they will play at least one season. So what is the probability that a student randomly selected plays in neither season? So what this one is saying is that no sports, right? So no sports at all. So that is another way of saying, well, that's the not fall, not spring, the complement of fall or spring. We're not doing fall or spring. Well, we actually figured out fall or spring. This is 1 minus the probability of fall or spring. So it's 1 minus 0.77, so we get 0.23. Go ahead and give this next one a try. Press play when you're ready to see the solution. And there you go. Now, when we're talking about mutually exclusive events, the intersection is 0, right? There is no overlap. So when we're trying to find the union between the two, we would just add the two probabilities. There is no overlap here. Another way to think about this too is if you want to determine if two events are mutually exclusive, so if they're mutually exclusive, then their intersection will be 0. So that's a great way to determine if two things are mutually exclusive. So this is asking, are A and B mutually exclusive? Well, if they are mutually exclusive, then their intersection would be 0, but their intersection is not 0. So no, they are not mutually exclusive. So what is the probability that A or B occurs? Well, that's the probability of A plus the probability of B minus the intersection. So that's 0.20 plus 0.30 minus 0.10. So the probability that A or B occurs is going to be, oops, sorry, I lost my notes there, 0.40. Samantha Green, a college senior, contemplates her future immediately after graduation. She thinks that there's a 25% chance that she will join the Peace Corps and a 35% chance that she will enroll in a full-time law program. What is the probability that she joins the Peace Corps or enrolls in law school? So we've got an or here. So basically we need to determine, can these things happen at the same time? Are they mutually exclusive? Is there any intersection? And it's kind of implied here that she's not going to do both the Peace Corps and the law school. So if we were trying to find the probability of the Peace Corps or law school, we would normally do the Peace Corps plus law school, oops, and then subtract that intersection. But we know that she's not going to do both, so we can just kind of add these two together. And the probability that she is going to do the Peace Corps or law school is going to be 0.6 or 60%. So when we talk about conditional probability, we're talking about something that given another event has already occurred, and we use this line symbol to represent that. So if we're talking about A given B, this is the probability of event A given B. So finding a job given that you have prior work experience. These are the formulas, and these are really important. We're going to be using these a bunch. And one way I like to remember it is just whatever we're given goes in the bottom, right? So whatever we're given goes into the bottom, and it's the probability of both over what the probability of what's given. An economist predicts a 60% chance that country A will perform poorly and a 25% chance that country B will perform poorly. There's also a 16% chance that both countries will perform poorly. Oh my goodness. Okay, that's a lot of alliterations there. Okay, so we've got the probability of A is going to be 0.6. The probability of B is 0.25, and both, the intersection here, is 0.16. What is the probability that country A performs poorly given country B performs poorly? So the probability of A given B. So that's the probability of both over the probability of what's given. Well, we have all those numbers up there. So we type that into our calculator and we get 0.64. That is the probability. We'll do one more example together and then you'll give it a try here. So we're given these values, we're going to calculate. So if we're given the given, this is the conditional probability, they want to know the intersection or the union. So if they want to know the probability of A intersect with B or A and B, we can kind of do some reverse things here. So we're trying to do, we want to know this, right? But what do we know? We know that the probability of A given B is, let's use the formula here. We know that that's the probability of the intersection, which is what we want, right, over the probability of B. So let's just kind of plug these in here for a second. So we know that this value, the probability of A given B, is 0.45. We don't know this, but we want to know that. And we know the probability is 0.3. So we can actually just multiply both sides by 0.3 and get our intersection there. So when we multiply both sides by 3, we get 0.45 times 0.3, we get 0.135. So this is equal to 0.135. So now it wants the probability of A or B. Well, remember that the probability of A or B is equal to the probability of A plus the probability of B minus the intersection of A and B. Well, the probability of A is 0.65 plus 0.3, and we got the intersection is 0.135. So when we do all that math, we get 0.815. And now they want the probability of B given A. So the probability of B given A, let's write the formula, is B and A, but that's the same as A and B. So we know that's 0.135 over 0.65. And so we get 0.208. So go ahead and give this one a shot and press play when you're ready to see the solution. We're going to pause there and continue this section in another video, so make sure to take care to watch part 2.